this course is like what is environmental humanities, and we have to keep coming or navigating back and forth to this question. And why environmental humanities? Because this is also another very significant question that I think I had raised in our previous class, and this is something which we have to keep raising. And then how environmental humanities? So if we know that this is the context, and this context demands a different or like more comprehensive and an inclusive frame of analysis, a more inclusive and comprehensive and all encompassing perspective to actually understand the relationship between society and nature. So once we are convinced with that, with the fact that today's context, we don't have, it is a compelling context, and we don't have any other option but to try to perceive or rethink the relationship between nature and society. Because the way we currently understand the relationship between nature and society, unfortunately, it is a bit problematic, and it is reductionist also to a great extent, and it unfortunately provides whole lot of weightage or acreage to human beings, and that is why this terminology anthropocentric, this is from where this anthropocentrism or anthropocentric has evolved. So, and anthropo means human beings or man more specifically. So everything is understood or perceived from how human beings understand the world. So I think like it is very important now to kind of to craft a departure, a transformation from this anthropocentric to a non-anthropocentric understanding of the world system, and also about our collective co-sharing of the planet Earth, or collective cohabitation of planet Earth with all other species. And that is why, and that is where these two particular concepts called interspecies intersectionality or entanglements or sorry, and entanglements are like key concepts within environmental humanities. And this is something which so for example, entanglement is something which physics also describes in its very own way. So for example, if you also look into the quantum physics theory or understanding, you will see that physics talk about systems, and how it looks into systems as an assemble of multiple actors, multiple phenomena, multiple events together. So this concept of assemblage is there in several other domains, and also several other disciplines and frameworks provoke us to understand entanglements and intersectionalities and things like that. But what is very unique about environmental humanities is that it is very interdisciplinary and transdisciplinary in nature. Now, what is interdisciplinarity and how interdisciplinarity is different from transdisciplinary, or rather how transdisciplinarity is one step ahead of interdisciplinary? These are the things that we will keep discussing, and you don't need to worry at all, because there will be a whole lot of free flow of exchanges, because I cannot help it. I cannot actually, kind of provide you with always, how do I say, like close-ended reading materials, or guidelines, or 10 points, or few notes to say that these are the notes, and you just mug it up, and you how do I say, like you then again kind of during your exams you just come prepare with these notes, and then you will be having the grip on this particular course. No, it will not happen like that, because this is an evolving subject, and all of us are evolving together with environmental humanities, right? So my point now is that if we, or once we understand the rationale, so this is very, very important, the context, that why are we discussing environmental humanities, what led to the evolution of the subject, why scholars, experts, practitioners, students, people from different parts of the world, they started coming together and come up with a subject, come up with an umbrella discipline, an umbrella framework that actually encompasses several other frameworks, to have a rethinking and reconceptualization and redefinition of our relationship with nature. Right. So once that context is clear, that yes, now we are almost on the no, we are on the, what is that called? No point of return. So we have already caused irreversible changes to the planetary system. but still we have to keep functioning. And again, when I'm saying we also have to keep in mind that it is it is like it will be foolishness to put such kind of strong agencies on us. We have to little bit step we have to step back and understand that we are not the sole agents. We are just part of this entire system, and we are just one actor out of multiple and many actors that that together play a role in the co-functioning of the planetary system. So these are few very in-depth understandings that we need to inculcate and harness, because then if it percolates, it infiltrates our cognitive domain and percolates deep down into our, how do I say, into our like entities and start shaping our entity, then the kind of solutions that we will be coming up with, whether it is a technical solution, it is hard infrastructures, engineering solutions in different forms and formats. So those solutions then of course will be more human, more than human and more human, and I think will serve better purpose for the society and for the planetary system at large. So it has an agenda. So this is not just a course, or it is not only a domain, but it is a conviction, it is an agenda, it is something that would enable us to evolve as as maybe like better human beings, because we will then start empathizing with all other actors who are co-actors and co-passengers with us in this mega journey that we are actually kind of encountering. But then how do we do this? How do we go about it? So when I'm philosophizing, it's, Aditya mentioned in the last class that it's quite interesting to listen to all these things. But then of course, back of the mind, always all of us have this question that how can we do this in a more technical way? Because we have to have data, we have to have data sets, we have to have numbers, we have to have more concrete understanding of the fact that yes, this is Anthropocene, and this is like a particular period or time period or geological epoch which is different from our preceding periods, and that is why within this transforming context we don't have any other option but to re-ontologize and reconceptualize this socio-nature relationship. Now, in today's class and in tomorrow's class, what I'm going to do is that I will be placing the context before you with hardcore technical data and with like research or researches which are being pursued, which started like 20-30 years back by very like renowned and very sophisticated natural scientists, people having expertise on climate science. And when I say climate science, again, climate science is also a very big and a broad domain which kind of accommodates knowledge and methodologies and methods from several other disciplines, mainly natural sciences disciplines, and yes, natural sciences disciplines only. And there are like few very big and very renowned institutes in the world which actually do a lot of research, like path-breaking, cutting-edge research works on climate science, and which includes, like, for example, the Potsdam Institute, and then Stockholm Resilience Institute, and there are several other institutes, but these two are like I think they are at the topmost rung of the hierarchy. So Potsdam and Stockholm. So in Stockholm Resilience Center, SRC, Sweden, 20 years back, almost 23 years back, few scientists under the leadership of Johan Rockström, they started researching on the transformations in the planetary system or the Earth system. And they came up with a boundary after like almost 10 years of research, almost like 1 decade of research, because they use or they kept using very sophisticated simulation tools and several computational and simulational techniques to actually come up with this data. And when we will be seeing this, we'll be actually going through this, you will see that it is very technical, and it's not so easy to generate quantitative sets of data to say, this is currently the level of, this is the current level of pollution, or this is the current scenario so far as, Earth's fresh water supply is concerned. And also to figure out, the relationship between different boundaries that they actually propose. So, for example, how changes in land water use can actually have repercussions on, drinking water supply in another region. So there are cross-scale complexities and there are cross-boundary interrelationship. But this whole framework or this approach called 9 planetary boundaries framework, to me, like it is very, very significant. It is one of the pivotal concepts to which absolutely validates that why we should be bothered. So the first thing we need to have clarity there, man, is the fact that it is important for us now to be bothered. We should be at the botheration stage, because what is happening now is like for the first time that is actually happening. So as things are happening for the first time and things are happening very radically, very fast, and taking intensified augmented forms, so no more we can just keep sitting and saying that, we keep mugging at the definition of like sustainable development, that it is that development which helps a society to develop or to increase its GNP, but not do much harm to the environment, because we need to think not only about our consumption patterns, or rather we not only should not only be thinking about our own generation, but also the future generations. Because if we keep exploiting the earth, if we keep overutilizing the resource base, then our next generation will not be left with anything else. So this was the very classical, sustainable development kind of definition, which the United Nations came up with in its Brundtland report and Agenda 21, and the same old story. But who are the next generation? And very interestingly, I just got a thought one day when I was taking a walk, that who are this next generation? We are that generation. So it doesn't make any sense. It's meaningless if we give the definition of sustainable development like that. If we use that same old definition, which was formulated in 1992, because we are that generation. It is not our next generation, but we are already that next generation. That story has started, right? So if we not, we don't have any other option but to keep on experimenting with ways, to keep on innovating technologies, to keep on involving anyone and everyone under the sun, to actually address this issue of sustainability. If we really, if we don't want the doomsday to be fast. Now, when I'm saying this, again, the idea is not to provide or place declensionist narratives that everything is, at a decline and there is no hope and the pandemic is there, and, within next 20 years or within the next 20, 30 years, everything will get finished, so it's useless. No, not at all. Because the whole idea and the way environmental humanities scholar look into things is to, one, acknowledge the catastrophe or crisis, but two, which is complementary to the first proposition, that acknowledging the crisis, not to deny the crisis. Like the US prime ministers, and unfortunately some of these gimmicks being followed by Indian prime minister, etc., that everything is fine. No, it's not true. Things are not fine. So we need to acknowledge the crisis, but at the same time imagine possibilities. So as we are acknowledging crisis, does not mean that we are already encountering the doomsday. No, there are several examples, lot of examples, lot of practices, lot of strategies, lot of mechanisms already are there, to which have been able to kind of generate impact on society. Maybe sometimes the scale may be little less, but that doesn't matter. It's not that everything has to be applied at scales, because if you try to apply everything at scales, then what happens is that you forget to accommodate or incorporate local cultural and local ecological dynamics. That is also something which is very, very important. How engineers should remain extremely sensitive to local ecologies and local cultural practices, for a particular geography with which or on which they are working. So you cannot, kind of implement same size fits all kind of solution across every context, and that is one of the reasons why our policies don't work, right? So anyway, this discussion will go on and on. But what is most important right now is to acknowledge the crisis, so that we can imagine possibilities, and so that we can understand how we have to imagine possibilities. So if we have a more concrete grip and grasp on the current situation, so if we have done a very good, situational analysis, if we are absolutely comfortable with this scenario, by comfort I mean that if we have knowledge, if we have adequate knowledge about the current scenario, then we will be more equipped to understand the complexities. We'll be more equipped to understand, problems by applying systems thinking perspective, and then we'll be able to innovate or come up with better solutions. And by better solutions, I mean that solutions which will be more sustained, which will be sustained, long-term solutions, and more resilient, and of course inclusive, socially just, and democratic, right? So this class and the next class, first few minutes, or maybe the first hour, and followed by that, then what could be the different frameworks through which nature culture relationship should be understood. So these two classes, or these 2 days, should be dedicated towards this. So with this, I would now request you to watch a video. So it is one of my recorded videos actually, which I used in one of the NPTEL lectures, but it is not only something which I have used for my urbanization environment course, but this is something on which I'm working since the last 6 years. But when you now be watching the video, it is nothing new. I have just used 30 minutes or 32 minutes to explain the 9 planetary boundaries framework, what I had learned from Stockholm Resilience Center and this particular scientific group. And I should also say that they have updated it with more facts and figures since then on, because this is something which they published in 2009. But after that, lot of changes, of course, because you have to understand it's a very, very dynamic system. Earth system is a dynamic system. But anyway, I think this 9 planetary boundaries approach or framework can be considered as a very significant entry plane or entry point for us to basically understand why environmental humanities, or even there is another question preceding it, that what is the context that we are currently inhabiting, Anthropocene. Then what is Anthropocene, and are we sure we are in the Anthropocene? How are we so sure about this? So can we validate that yes, we are in the Anthropocene? And I think that 9 planetary boundaries framework or approach is a major validation model, to basically attest and confirm that a lot of transformations are taking place or started to take place on the Earth system since the last 70 years at least. Actually, it also dates back to industrial revolution and all, but significant changes since at least the 1950s, because it was from the 1950s that geologists started identifying and figuring out major changes in stratigraphic signatures of the planet. Right. So without wasting further time, just I would like you to watch this particular video. And I don't think we will be having time today to take up questions, but tomorrow, of course, we have to discuss this, because this is very, very important. So just so topics, the readings are here. So I'm using one particular video file from here. Lecture 3, this one. I'll use the tab view maybe. So can you see this? See and hear this?
Yes, ma'am. Yes, ma'am.
Oh,
So in this presentation, the focus would be on the 9 planetary boundaries framework. So we will discuss several concepts within the 9 planetary boundaries framework, and these concepts are the 9 planetary boundaries themselves. What are these 9 planetary boundaries? And before knowing this list of 9 boundaries, we also need to know that what are thresholds and what are boundaries as part the conceptualization or assessment of the Stockholm Resilience Center, and more specifically Johan Rockström and his team will discuss that. And we are also going to talk about the interactions or the overlaps, the overlapping interactions and the feedback loops across these 9 planetary boundaries. So we would, and this is related to this cross-scale complexities. So we will see that how these planetary boundaries, they converge, they interact with each other from local, regional, continental, and planetary scales across all these 4 scales. So we had discussed in the last presentation that how the period of Holocene was a period of stability, but then the irony of the Holocene was that as the epoch visualized or encountered growth, economic growth. So this exponential economic growth after a particular point of time, it had impacts on, it kind of destabilized the biophysical components or processes of planet Earth, and caused abrupt and irreversible changes on environment, and unfortunately with a deleterious and oblivious effect on human well-being. So we can see, or we can understand, this we can understand this relationship between economic growth and ecological sustainability is inversely proportional. Okay, so so as this exponential economic growth had a lot of impact on the environment, so finally it became very important to kind of search or to identify what would be the safe operating space, SOS, for humanity. Now, this man, Johan Rockström, and his team, they did a brilliant, they conducted brilliant research on kind of quantifying the thresholds, and but they also discussed the limitations of quantification as a method, or the limitations of quantification procedure, and I'll discuss all this. But what is most important is that I think personally I also feel that the contribution of this Stockholm Resilience Center, Rockström and his team, has been enormous in terms of formulating this framework called the 9 planetary boundaries to kind of validate the scientific truth of the present epoch of the Anthropocene. Yes, so they were Earth system scientists, and they wanted to kind of trace these Earth system processes by identifying key Earth system processes. And how this could have been done through the quantification of the boundary level for each of these Earth system, or for each of these biophysical processes and components. And the final argument was that that if these planetary boundaries are transgressed, if they're crossed, then then we will be in major trouble. So so this transgression of boundaries will trigger, or each time a boundary is crossed, it triggers like a global environmental transformation or change at an irreversible scale. All right. And I think this particular quote by Rockström et al. Is very, very significant. And to me, the key word is non-negotiable. Non-negotiable is the key word. So these are the planetary preconditions which are non-negotiable. So which means that that we have to perform, or we have to kind of we have to keep our economic activities in control. We have to develop or innovate methods, mechanisms, small scale practices, environmentally benign processes or technologies. That's a different discussion altogether. But what is most important is that through this planetary boundaries framework, they could finally talk about the non-negotiable, which means conditions with which negotiations are no more possible. So I personally, I very much, I am quite influenced by this framework. Why? Because they try to address this particular question, I think, which is the question of this century. And what is this question? This question is, what are the non-negotiable planetary preconditions that humanity needs to respect? And this is the second keyword. This is the second keyword, a second most important keyword to me, because we really need to respect, these non-negotiable planetary preconditions. And why do we need to respect this? For our own benefit, for the larger benefit of planet Earth, for the larger benefit of, all other species with which we cohabit, this particular planet. So what are the non-negotiable planetary preconditions that humanity needs to respect in order to avoid the risk of deleterious or even catastrophic environmental change at continental to global scales? So these again remain so very important, that these changes are occurring across all scale, from local to regional to continental to global. And so we discussed that, in the Holocene period, maybe, the planet also encountered some changes, some ecological changes, but the repercussions were not enormous in terms of spatial scales. But now the kind of changes that we are encountering, we must remember that, these changes, they are occurring at every scale, at all scales, across local, regional, continental, and global scales. So you have to remember, this particular question, which is so important and which is so loaded, and which explains the context, which explains the reason or the rationale, which validates the rationale that why the Stockholm Resilience Center and why Rockstorm and his team plunged into this robust exercise of coming up with a framework through which their Anthropocene could actually be kind of questioned and also validated, more importantly. So Rockstorm talked about thresholds and boundaries. So they use these two concepts to kind of quantify, these changes in the biophysical processes of the Earth system. So what are thresholds? So thresholds they explain thresholds as non-linear transitions in the functioning of coupled human environmental systems. So these are non-linear transitions, for example, which can be explained through the recent abrupt retreat of Arctic sea ice caused by anthropogenic global warming. And, they pointed out, they explained that for all the different biophysical processes, the thresholds are actually not known. So, for example, and also the whole idea that these thresholds, they are the intrinsic features, or they are the non-linear features of these biophysical processes, which are also determined by the position of control variables. So, for example, the temperature, or for example, ice albedo effect. All right, in case of sea ice, for that matter. And I was saying that it was difficult to because all the thresholds are not known, so it's not possible to kind of have a concrete knowledge and understanding about these thresholds. So, for example, land use change. So, for land use change from the continental to the global scale, the threshold is unknown. But on what basis then they did the calculations, So, for example, though the threshold is not known from continental to global scale, we are talking about land use change, but at least, this has been validated that through through a continuous decline of key ecological functionings like carbon sequestration for that matter, and if this keeps on getting accumulated or aggregated, then definitely it will trigger or it will have an impact on on a global scale threshold, for that matter climate change. Again, at the same time, this will also impact local or regional scale processes, like by bringing down or maybe having some impact on the threshold in terms of like lakes or reservoirs or forests, all right, like savannas, etc. So the whole idea is that through by a proper understanding of or a proper mapping of increase or decline or decrease of key ecological functionings, some conclusions could be arrived at. Now, what is a boundary? So the boundary is actually human determined values of the control variable set as a safe distance from a dangerous level, and that is why this showed, and they said that crossing each boundary will be extremely problematic, because then our survival would be at stake. The survival of planet Earth would be at stake. So this boundary remained a very important concept to kind of to set this safe distance from a dangerous level. But then again, as thresholds, most of the thresholds are unknown. So we don't know, we don't have concrete data about thresholds. It's and these are unknown. So definitely, the limitation in this boundary concept is that as it depends on the knowledge relating to thresholds. So and as knowledge about thresholds are not have not come down to us, so there is a whole lot of uncertainty about this. So already, this boundary framework, it has this problem of uncertainty ingrained in it. And there is another point which I would also like to highlight here, that is, it's not only the uncertainty in the quantification process in terms of uncertainty about the threshold, but it's also about there are some normative judgments which are also there in this process, because for example, how different complex societies would respond to the risks and uncertainties, these are also some questions, and we don't have really a hardcore numerical data on this. So it's quite difficult to kind of make linear conclusions or statements so far as these boundaries are concerned. So it has its limitation, but at the same time, this is important because at least it enables us to kind of be more aware and also engage ourselves in this process of understanding the changes in biophysical processes of planet Earth caused largely by economic activities of human beings. So human induced planetary change. Now, this planetary boundaries framework, again, it rests on three key scientific inquiries. So the first addresses the scale of human action in relation to the capacity of the Earth to sustain it. So human action on one hand, and then the capacity. So at what point, at what particular point the Earth actually reaches, its saturation point. All right. So the capacity, so the carrying capacity of the Earth. So the scale of human action in relation to the capacity of the Earth to sustain it. And I must say that it draws largely. They drew largely from the ecological economics frameworks. And for example, the works initiated by Costanza and his team. And the second is the work on understanding essential Earth system processes. So here they drew heavily from sustainability science and from Earth system science. And the third is the framework of resilience and its links to complex dynamics and self-regulation of living systems, emphasizing on like multiple basins of attraction and threshold effects. So these are the three important scientific inquiries on which the planetary boundaries framework actually rests. And again, Rockstrom, they argue that the first step by identifying biophysical boundaries at the planetary scale within which humanity has a flexibility to choose a myriad of pathways for human well-being and development. This is a very, very important statement, which is close to my heart, because they said, they say that it's not a doomsday message. It's not a doomsday message, but this exercise is important. This exercise is important because through this exercise, we'll be in a position to kind of identify, these biophysical boundaries at the planetary scale, at the global scale. And then we will understand that what are our limits. So what is a boundary, and we also discussed about this non-negotiable planetary preconditions. So if we are aware of of each boundary, then we will be in a position to think about our next course of actions. So then we can choose, we can select a myriad of pathways, for our own being, for our own well-being, for the for the well-being of the planet Earth at large. So these are the 9 planetary boundaries: climate change, loss of species, biodiversity, extinction of species, addition of phosphorus and nitrogen, so phosphorus and nitrogen cycles, deforestation and land use change, emission of aerosols, then stratospheric ocean depletion, ozone depletion. So this is ozone depletion, stratospheric ozone depletion, and ocean acidification, freshwater use, and dumping of organic waste, so chemical pollution. So these are the 9 planetary boundaries which they identified, and they also, this group made a distinction between boundaries which were directly related to sharp, planetary scales. Here you can see the distinction, and also the slow boundaries where there is no clear-cut evidence till date about the threshold, and which also shows the underlying resilience of planet Earth in the form of functioning as sink, and also regulating water, then mineral and other the other mineral nutrient fluxes, etc. So this distinction is also very much there in this in the identification and mapping of these 9 planetary boundaries. And I think one important point is that though they made this distinction between more direct and rapid variable and slow variables, but till they kind of provided a warning. So there is also a warning note in this distinction, that if even slow variables they keep on aggregating and accumulating for a period of time, then of course they can trigger major changes at the planetary scale, for which we really which should draw our concern, So this it's important to understand the nature of these boundaries and how these processes are at play across, again, the interplay of constant and not so constant variables. And also they talked about large scale or maybe planetary scale processes, like for that matter climate change, which also has a lot of impact on sub-Earth system processes and scales. So for example, this climate change, it is itself at least associated with the 9 subsystem tipping elements, which are all sensitive to climate change. So I think the beauty of this planetary boundaries framework is that it also addresses the cross scale complexity. So the cross scale complexities have been addressed quite systematically and scientifically in this 9 planetary boundaries approach. So this is a very complex table, and in the reading list, you will see that I have provided you with this reference. This is this article by Rockstrom and his team, which was published in 2009 in Ecology and Society. And you have no option but to really go through this article in great detail if you have to have a better understanding of this 9 planetary boundaries framework. And it will be crucial not only for this urbanization and environment course. Of course, you have to have a great deal of understanding about about Anthropocene and Urbanocene and all other scenes like Technocene, Capitalism, etc., which we'll cover in our subsequent lectures. But I think this is very, very important for researchers who are working in the domain of the environment, be it from the natural science perspectives or the social science perspective, or a combination of both. So please, you cannot avoid this framework and this article by Roxham and team. And this is the table, and this table itself is it's loaded, but at the same time it's quite explanatory, self-explanatory. So it's explanatory by itself. So I'll not go into the details, but here they talk about all these Earth system processes, the control variables, the boundary as a zone of uncertainty, and what is our knowledge. So what is our knowledge about each boundary? But just a disclaimer that the data is not updated here, because this is the data which pertains to this 2009, because this article came out in 2009. But after that, Stockholm Resilience Center has conducted a number of research on kind of updating this information. So, and you will see that I will also talk about this in the last leg of this lecture, that by now how some planetary boundaries unfortunately have already been transgressed. And because here also, like if you see the table, it also talks about how climate change, the first boundary, has already been transgressed. So we are not in the safe operating space so far as the first planetary boundary, that is climate change, is concerned. So this is again a very significant simulation diagram or a simulation model, which was developed by the CCM3 climate model. And this simulation model, it clearly shows the interactions and cross-scale complexities which are there in terms of changes in a particular region, and how a particular change in a specific region can have a whole lot of impact on other spatial sites. So what are the cross connection, what are the interactions, what are the overlaps, what are the cross-scale complexities that this through which can also be understood by applying or by deploying this 9 planetary boundaries framework as the frame of analysis. So here, for example, I'll give an example. Let us take the example of Amazon forest, right? So Amazon forest, in the Amazon forest, a considerable amount of water is recycled through vegetation. All right, and the forest also, forest and vegetation also, like it flushes aerosol particles, and these aerosol particles are again this aerosol particle remains crucial for the formation of clouds. All right, and if there are changes in concentration of particles, so if there are transformations or there are changes in particle concentration, then it can impact the rains, precipitation, and also the strength of the convective circulation on that region, on that belt. So this can again have some form of impact on on aerosols itself. And moreover, like this deforestation, deforestation and land use change in Amazon, it definitely it has a lot of it can trigger change. It can destabilize the regular precipitation pattern. And this can again have an impact on the vegetation and on the aerosols. So this is a clear-cut example of a feedback loop that is there in the Amazon basin, and one can understand that if this change continues for a long period of time, then there can be replacement of the entire Amazon, so that we can see a change in the nature of the Amazon forest, where it can even transform into a savanna like forest by the end of the 21st century. So we can understand how this feedback loop actually works. Now the next argument is that these interactions are not only limited within this regional scale of the Amazon, but it has more advanced repercussions. So for example, it will not be an exaggeration if I say, and this has been proved and justified with the simulation model, that changes in Amazon, it will influence, it will have an impact on the surface temperature of Tibet, for that matter. So like, for example, the changes in precipitation level, it can affect the energy balance of the convective circulation, and this can cause a northward shift of the intertropical convergence zone, which will again have an impact on the weather conditions, and finally this will affect surface temperature in Tibet. The story does not end here. So the surface temperature change in Tibet will have repercussions on the water resources of Asia. So for example, this 15,000 glaciers in the Himalayan Hindu Kush region are responsible for 12,000 cubic kilometers of fresh water for this entire basin, for this entire region. And I mean, it caters to the need of like 500 inhabitants, 500 million inhabitants, and plus an additional like 200 million inhabitants in China. And so this change in this glaciation pattern, changes in that glacier belt, it will definitely have impact on floods, and in the short term it can cause increased runoff. It will trigger floods or flood events, flood vulnerability in the region, and it will have sets of impact on precipitation variability. So you can understand that how all these planetary boundaries are interconnected to each other through this cross-scale interactions and overlaps. Yes, so I was also talking about the transgression of the boundaries. So you can see that how yeah. So out of these 9 planetary boundaries, how already we have kind of crossed. So these are crucial thresholds, and unfortunately no more we are in the safe operating space so far as these 4 thresholds are concerned. So you can take a more detailed look into this slide to get an understanding of our present situation, because that's the idea. Through planetary boundaries, we need to know and understand our present situation so that we can design and develop and innovate, strategies through which we will be in a position to remain within this safe operating space. Yes. So these are the references again, and I would definitely, you have no option, but you have to go through the particular article by, yes, by Stephen and Rockstorm and team, and so these 2 articles. So this one, which which
Yes. So this was the boundaries framework all about. So you will see that I have I have uploaded a few readings in topic in the readings folder. So there are the two PPTs. So PPTs, you can just take a look. But more important will be these two video files, because first one is a bit like it is a more general one on the Anthropocene. It's not very technical. But the second one, this on 9 planetary boundaries, is a bit technical. And I would really, really encourage you to go through the 2009 article by Johan Rockström and team. So there are many co-authors you will see. And this article is also a bit heavy, honestly. And like it has lot of technical details to share. And also they have discussed in detail that how they came up with the methodology through which they could quantify this data. And they also have discussed the limitations that for example, so far as few boundaries are concerned, like most importantly pollution, why it is not possible to quantify each and every variable, to map and understand pollution levels. And few things are also very dynamic, so there are like hidden and like there are hidden variables as well, and it's not easy to kind of explore those hidden attributes and variables. So this is a very, very technical article for sure, but I would definitely encourage you to go through the whole article first, to watch the video once more and then go through the article, because this article will not only be important for you for this course, but honestly, like this is a very path breaking article, and the knowledge of which you can use I think it has a very general and a universal application. So I will definitely ask you all, and I'm sure that you will be able to do better justice to this article than me, because I come from a very non-technical background, but you people are much more equipped than me, so far as technicalities are concerned. So please, it will be a bit difficult, but you can spend 2-3 hours and you can kind of grasp the article, or the details that have been fleshed out in it. So this is what I wanted to say. And like if you have any question now, because we just have 2-3 minutes left with us, you can raise a final quick question, and then we'll continue tomorrow. So any question? Do you have any question, any botheration, any concern, anything you can ask, so far as this topic is concerned and other things. Could you understand I mean, the video file was okay? The how do I say? The presentation was all right for you? Huh? The presentation?
Yes, ma'am.
Absolutely all right? Okay.
Yes,
okay, thank you. So any concern, anything you have that do you think it is a bit too much? I don't think it will be a bit too much. And also, like, I wanted to thank Roshan and Pranav for taking very for coming up with this key highlights document for our last class, and really enjoyed going through that document, and it is there in the G Drive folder. And I initially was thinking that whether I'm not circulating any template, but I think the way they just the way they did it, it's absolutely fine. And I know it can be considered even as a standard way of doing it, but again, topics will vary, so you can add your own flavor. I will not it's not that I will not remain flexible, so you do it yourself. But I'm sure that when at the end of the course, we will have plenty of these documents. And what is very good about these documents is that we then have a chunk of whatever we have discussed, and which will not be available in textbooks or other platforms, but it is something which has kind of, or which will be evolved from these live classes, so which include what I have said, the points that you had disagreed, or the kind of agreements and disagreements that you had shared, and it's our collective output. So I'm very excited and looking forward to the class highlights and evaluation and those things. Of course, those are there in my mind, and I also know that I have to share a plan, a more concrete plan on evaluation and assignments that I'll do. Just give me one more week maybe, and I'll discuss it with you, and it should not be a problem at all. So who would like to come up with the class highlights documents for this class?
Ma'am, I am ready.
I'll do it.
I'll do.
Harsh, and who will accompany Harsh?
Ma, Abhijit.
Ma'am, I am ready. Ma'am, I
Abhijit.
can- Yes, ma'am.
Okay, Harsh and Abhijit, very good. So thank you very much, Harsh and Abhijit. So then I will expect the document from you two, and tomorrow also maybe I'll ask someone or two people, 2 or 3 maybe, because tomorrow we have a big class. So together I will maybe request you to circulate the document to me on Friday. Possible? Friday night or maybe Saturday night?
Yes,
Yes,
ma'am.
ma'am.
By today
Okay.
only we'll try to do.
Okay, very good. So thank you very much. I'll meet you tomorrow at 8.
Okay, ma'am. Thank you.
Okay, thank you. Shaurodip, can you make a note that Harsh and Abhijit?
Yes,
they are-
ma'am. Yes, ma'am. I have already noted. Harsh, Vardhan Goenka and Avijit Singh
And
for
Abhijit.
this
ठीक.
class. Okay. ma'am.
Okay then. Okay. See you all tomorrow. Bye.
Thank you, ma'am.
Have a nice and productive week.
Thank you, ma'am.
Ma'am, thank you.
Thank you,
ma'am.
ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.